And so we have a lot planned today. It's going to be a fun day. A lot of hard work, but a lot of fun too. So some of the housekeeping this morning. We will have some surprises today, some really big and good surprises. So keep an eye out for those during the day and later tonight. Tomorrow, we're not going to do this in the morning. Tomorrow, you're going to go directly to your session and start in the morning. And then we're actually going to get back together here at noon. And Jim Zemlin, who's the executive director for the Linux Foundation, is going to provide a keynote for us. Jim was with us before, I think last year in Santa Clara at LCU13. Always a really interesting guy, always has interesting and relevant stuff to talk to us about. So be sure to be here at noon, but go directly to your sessions in the morning. The hacking rooms are going to close today at 6. So that basically means if you have any stuff in there, you want it out of there by 6, or it's going to disappear and you're going to be chasing it around, and that's not going to be any fun. And some people have their demos for Demo Friday tomorrow in the hacking room. So around 6, if you could move your stuff out and move it into Grand Peninsula G, and then tomorrow morning, first thing, you can start to set up your demo in Grand Peninsula G. Okay? That should be a good day too. We're excited for tomorrow as well. There are some template slides, as is our custom. We're going to do a round of summaries from all the working groups and everyone from what went on this week, and you'll get your template slide today. So look for that, and you can start to work on that stuff. Today is LNG Day, Linaro Network Group Day, and LNG is really cruising this week, right? A lot of really good sessions, a lot of interest. The ODP, the Open Data Plane stuff, is through the roof in terms of interest and activity that's going on there. Some great stuff. And we have a great keynote speaker, Christopher Colias, who's a senior research scientist from Orange, is here. He's going to talk to us about NFV and how it empowers the network, and this is one of the hottest topics in networking. So some really good, interesting stuff there. There are network sessions throughout the day, and there are a bunch of demos, and there's a lot of people that worked hard on these demos. You should be sure to check these demos out. They start about 2 o'clock in Grand Peninsula E, and they'll run all afternoon. The theme of it is free your data plane, and there's hardware. ODP will be running on a wide variety of hardware, truly cross-platform, and a number of the members have also worked hard on demos, so it should be really exciting, really interesting stuff this afternoon. So it starts at 2 o'clock. Be sure to check that stuff out. Tonight is the member services dinner, and I can confirm that an Elvis sighting has been made near the member services dinner. So we'll have Elvis joining us tonight at member services. We have a bunch of other surprises there. As I mentioned, it's at this place, this private collection of memorabilia place called Sparky's Hot Rod Garage. It's going to be a lot of fun. Buses actually start to leave at 5:30. So from the lobby, from the exit where you come into the hotel. So if you could be down there and get on buses, it's only 10 minutes away from here, so it's a really short drive. It's in San Carlos, and it's going to be a lot of fun. We've contracted with this company called Emergency Barbecue, and they're going to be there this afternoon, and they're going to cook the barbecue there. It's not going to be heated somewhere else and brought over. And if you go to their website, emergencybarbecue.com, I mean, you just get hungry just from looking at their homepage. This is some really good barbecue, so we'll enjoy that as well. There's some other fun stuff that's going on there. There'll be stuff for vegetarians too, not to worry if you're a vegetarian, and we're going to have a real blast. So hopefully everyone will join us. And now I'd like to turn it over to George Gray, CEO of Linaro.
Thanks, Joe. Thanks for the party last night. Good stuff. Well done, Arwen, and all the team. Thank you. Okay, so on Monday, I talked about 4 years ago. Assuming pretty much everybody was there on Monday, so I'm not going to give you the entire presentation again. But we started 4 years ago, and I said that today we had grown to 28 members, including ARM and IBM, and how much impact I thought that Linaro had made on the ecosystem. We also announced the Linux Foundation joining Linaro, and I'm really pleased to see Jim and to welcome Jim tomorrow, as Joe said, and I hope that you'll all come and visit and listen to his keynote. We also on Monday gave some live demos for the first time at any Linaro Connect, and we actually managed 2 out of 3, but due not to the demo itself or to the hard work of everybody who put it together, but due to the lack of some required hardware that didn't arrive when it was supposed to, we were unable to do the demo. It will be shown tomorrow on Demo Friday, but it was so interesting that we thought we'd just take 2 minutes beginning today and ask Mark Rogotsky from the Digital Home Group to come up and show you what's being done in the exciting world of 4K TVs and what Linaro is doing in this space. So, Mark.
All right, thank you, George. So we have a demo for you today. It was put together by the LHG team, particularly the folks from ST Microelectronics. The man behind the curtain over there is Christophe Rizzo, who did the bulk of the work. This is a demo of 4K cube rotating on, right now is just a slide with all the information of B2120 hardware, which is a dual Cortex A9 CPU, which is targeted for the set-top market. It has a quad-core ARM Mali 400 graphics processing unit. The build that was used is the RDK-based open-embedded Yocto, and we're baselined on the Linaro stable kernel version 3.10. We have some 4K slides just to show how impressive it looks. It looks great when you're right up to the TV, and there's something relevant for where we are. And now we have the 4K graphics cube overlaid on 2K video playback. As you can see, Christophe can also, in real time, move the rotating cube. There's no tearing of video. It all plays back smoothly, and it looks quite nice. So just a reminder, tomorrow you'll see all of the LHG demos, including this one. You can meet the team, ask them questions, and we'll have some other 4K activities as well as some of the other demos related to the sessions you've heard from LHG this week. Thank you very much.
Wow, and that's on Cortex A9s as well. I can't wait to see what ST are going to do next. So I'm actually really excited about what's happening in the Digital Home Group. And I kind of had a nightmare flash in terms of looking at that demo and thinking as we're going to move to a world where we have a whole wall that's going to be our TV screen, and we're going to be trying to watch the news on the right-hand side, and our kids are going to be playing video games on the left-hand side of the wall, and it's going to be interesting. Okay, so picking up from the announcements I made on Monday, one of the things we didn't do is kind of show the list of members, which is now increased dramatically, and at the bottom there you see IBM and the Linux Foundation. But there is just one more thing that I wanted to talk about today and make an announcement. The astute amongst you will have noticed that in this slide there are actually 30 members, which is more than 29. 28 plus the Linux Foundation makes 29. And I'm very, very pleased to announce that today Spreadtrum Communications have joined Linaro as a club member from China, and I'm very pleased to welcome them into Linaro. To do that, I'd like to welcome Diana Jovin from Spreadtrum Communications to come and give you a very quick overview of the company. Diana, thank you.
Thank you, and it's really a pleasure to be here as the newest member of this community. So just a couple of minutes. Spreadtrum, although I'm based here in the Silicon Valley, Spreadtrum is headquartered in China, and we do most of our R&D there. Our customers include global brands such as Samsung and HTC to design houses in China that provide handsets to local brands throughout the emerging markets around the world. We're now the third largest provider of baseband SoCs and represent about 16% of the global market. We provide everything as a turnkey solution, meaning not just the chipsets, but the full software stack as well to help our customers reduce the time to market and the overall design cost of making handsets. And we provide a very broad portfolio ranging from everything from LTE at the high end to single-core smartphone chipsets, as well as very low-end single-core smartphone chipsets. And just as an example of that, one of our customers about 2 weeks ago launched a smartphone with a retail price of $33 in India. We, of course, base everything on ARM architectures, and our core competency is really on these low-cost, affordable mobile platforms. I'll turn it back to you.
Thank you very much. Thank you to Anna, and congratulations. So we really look forward to welcoming Spreadtrum into Linaro and to having them fully participate at the next Linaro Connect. It's exciting times. Okay, so now on with the business of the day. I'm very pleased that over the last I think 12 months, there's been, since LNG formed, there's been an incredible migration, if you like, of interest in terms of networking equipment towards the ARM architecture. And who would have thought a couple of years ago that some of the segments that really, the market segments that didn't really have very much ARM in them at all, as the ARM architecture and the introduction of ARM v8 has really started, I think, to see a tsunami of migration to the ARM architecture in a number of segments that it just didn't that just didn't contemplate using this architecture before, thinking it was really just for mobile. And you saw yesterday what's going on in the server and enterprise space, but the networking space is incredibly important. And I'm very, very pleased that today we have Christos Kolias, who is a senior research scientist at Orange in Silicon Valley, which is a subsidiary of Orange Communications, the mobile phone operator in Europe. Christos is actually a co-founder of the Epc Nfv group that led the foundation of the wireless and mobile working group in ONF. And he's lectured on NFV and SDN at several industry events. So I'm really looking forward to hearing what he's got to say. I'd like to welcome him up to the stage. Christos.
All right, thanks, George. Thank you so much. Great audience. I'm here. You have a really great conference. It's been like the 4th day, I guess. I have one more day to go. I'm sorry that I missed all 13 previous conferences. So what I'll be talking today is about NFV, and the original title for my talk was Empowering the Network. And although it is network related, actually it's more about empowering the user themselves. And here, when I say user, it could be a developer. It could be a network administrator. It could be us as an operator. It could be anyone who's actually, part of the network operations. And it doesn't occur to me, because you have all these hacking rooms, that actually we're also going to empower the hacker themselves. So we'll see how this one is going to play out. So I guess I just need to. There's a clicker here. I can use the clicker. Actually, you don't. I just need to. Let's see if that's going to work. I thought that the screen was there. Okay. So the vision behind NFV is that you have all these different network equipments in the network today. So what you see on the left-hand side is sort of like the classical network model. We have all these different devices that are dedicated devices that have a specific role in the network. And these are very static devices that you don't move them around. They have one physical role that they play. So you have a deep packet inspection device, you have a firewall, you have a BRAS, or you have a session border controller, and so forth. And again, they're very static. And in fact, you have to dispatch someone to install these devices in your network, whether that's an operator's network, or whether it's a data center, or it's like your cloud network, essentially. And the one thing that I added in the original picture, we did not include that, which is just static devices, standalone devices. I also included the, if you can see here, the EPC architecture, because Nfv, it's not just about virtualizing boxes, but essentially, how we can change and hopefully how we can influence the way we design networks, and with the, so that's the EPC, where it in fact is an entire architecture that we're virtualizing all the boxes in that architecture, and we have to see what's going to be the impact of doing something like that. So that's the on the left hand side, what you see is the classical, again, network model, and what we claim is that in this virtualized environment, everything becomes a virtual appliance, essentially. And in order to achieve that, all you need to do is run these functions that are being virtualized. You have to run these on a bunch of servers and storage and perhaps switches. And this is going to be commoditized, essentially, hardware. Now, since you virtualize things, they're not static any longer. So things, this is like running on VMs. Most likely, these can be moved around as you move around your workload. So they're very, very dynamic. It's extremely easy to scale, and I'll come back to that later on and see what exactly we mean by that. And since they're like running on VMs, you can run different things on the same VM as required. So you see, it's a very dynamic environment. So that's what we need to get out of that. So initially, we identified a number of what we called fields of applications. Essentially, it's like examples of where Nfv is relevant. So it ranges from mobile networks to your home network. That includes the residential gateway, to application delivery controllers, to security functions, to tunneling gateway elements, traffic analysis, traffic monitoring. Anything that essentially, again, that runs as a standalone device in your network is relevant to Nfv. So what is the value proposition, again, behind Nfv? There's the EVA, what I call the EVA principle. It's about the flexibility to easily and rapidly provision a network function, which is virtualized. And you can actually stitch different functions and make a service and offer that as a service. It's all about also the speed to market, which is the velocity aspect of Nfv. Now that you can innovate faster. I was at a conference a couple of weeks ago. Actually, it was one of the conferences I was chairing, and there is an architect from Facebook. He was talking about the Wedge suite that they launched 3 months ago, and they were saying that they have a very different type of cycles with respect to their equipment. They work on a 3-month basis. They change the requirements every almost 3 months, and that's because they have a very dynamic environment of applications. So you see immediately that things like that, they become very relevant if that's your situation, or you can actually the type of market plays a very important critical role. And the last thing is the agility. Again, how you can actually offer new services. You don't have to wait for a vendor to come up with a new device or a new release. You can do that on software. Software is much, much faster to essentially innovate. And to that, you can also add scalability, because now since you're running things on VMs, all you need to do in order to handle any additional traffic in a network, like spikes that we see in our network as a mobile operator, for instance, all you need to do is launch more VMs. You can run those virtual network functions. Because in the past, of course, if you need to take care of that, you have to put more boxes in the network. So the other thing that obviously is going to become a collateral thing is the reduction in terms of CapEx and OpEx. I don't really emphasize that myself, because I like to see, first of all, some studies around, some techno-economic studies around the savings that we can achieve. But it's really clear to us that obviously, since you're visualizing things, that the CapEx is going to be the CapEx savings are going to be very, very relevant, and the OpEx savings as well. And OpEx here includes things from labor to your electricity bill and so forth. So obviously, reduction in operations cost is something that will happen, but we need to somehow quantify that later on. Open source is very, very important to us. Again, as you move things into software, open source becomes also very, very relevant. So we're very, very excited about that, and hence, you guys can actually contribute from that angle as well. Okay, so a few things about the group that we started a couple of years ago. It's under Epc. Epc is the European Telecommunication Standards Institute, and it's based out in Europe, but this is not a European, because I've heard that before. It's not just about European operators, right? It's more like a global type of collaboration. So we launched back a couple of years ago. We have more than 35 tier 1 operators from around the world. Any major operator that you know is on board. We have more than 220 members. And we have, the way we're structured, we have 4 working groups and 2 expert groups. We published the first set of specifications last year, a year ago in October, and there's going to be another release coming up sometime later this year. The other interesting thing about the Epc Nfv effort is that we have launched a proof of concept program, which has been very, very successful, because at the end of the day, you have to go out and implement the kind of things that we're preaching to the world, right? We say, okay, this is the architecture, but essentially, how do you deploy that, how you implement that, that's going to be always the case. So and that also, the way it works is that you have an operator with a minimum of 2 other vendors that participate in that POC program, and they make a proposal, and if that gets accepted, then they can carry on with their work. So this is a very, very exciting thing for us to, again, launch this proof of concept program. We have quarterly face-to-face meetings, as with any other standardization organization. We have 7 so far. The next one is coming up in Arizona. And we have a number of work items that we were working on. We published 2 white papers. So we've been quite active in this space. In case you're interested in downloading some of the literature, this is the website. We made it very simple so you guys can go. And this is the public area, so you don't have to be a member of Epc. And this is another interesting thing about Epc, is that even if you're not a member of Epc, you can participate. The only thing you need to do is sign a participant agreement, and I think pay 100 euros per day for the meetings that you attend. But other than that, it's pretty open. And that's one of the reasons, actually, we decided to go under Epc, because we think it's a very open organization. Again, openness is very, very relevant and very, very important to us. So, so one of the results and again, we've been around for like almost 2 years now, but we're very keen on releasing the reference architecture early on, just to lay the ground for the things that we're working on. So I'm not going to go through the different components here, but the most important thing to notice here is the VNFs. These are the visualized network functions. So those network functions that you visualize appear here. They have to run on your virtualized infrastructure. So NVI stands for virtualized infrastructure, and this is your virtualization layer, whatever you choose that layer to be. The other significant component in NFV is the management orchestration, which is the right-hand side the box that you see there. And that includes a number of other subcomponents, like the orchestrator, and I will discuss what the orchestrator does, the VNF managers, because you need someone to actually managing those VNFs somehow. And also you need the manager for the virtualized infrastructure. So again, this is the reference architecture as far as NFV is concerned. And in fact, we added the acronym there, end-to-end, because it applies to end-to-end type of applications. And you have a bunch of interfaces here, and as NFV, as a group, we try to define exactly those interfaces, because it's very important to make these interfaces open, as open as possible. But if that doesn't happen, at least you have to standardize them, and because you need that for interoperability purposes. So in terms of use cases, I'm sort of like coming back into the use cases issue. We divide the use cases into 2 camps. So one camp is the architectural use cases, and that includes the network function virtualization infrastructure as a service. Now, if you're like a service provider, perhaps you can use another service provider's equipment and premises to essentially extend, if you like, your service. This is almost like if you I'm not sure if you remember that, the roaming in the old days of cellular telephony, where you could actually use somebody else's network and base stations, to make a call or to access your your phone and everything. So so this is similar again to that. This is the one of the most important use case again. That will allow us to go into the cloud essentially, become like a cloud service, cloud telco essentially. The other use case is the virtual network functions as a service. Actually, I can offer something like a firewall or deep packet inspection as a service. We see that actually is happening today. Google made an announcement of their Andromeda platform back in April, and they say actually one of the services that they offer is like a firewall as a service. So this is already happening today, just to give you an idea that this is something which is very, very real. And then we also have other use cases. And the last thing here is the VNF forwarding graph. I'll come back to that because this is also very, very important and quite relevant to the work that you guys do as Linaro. So, and the second set of use cases is more like service-oriented use cases. That's where you see things like related to the EPC and the mobile packet core, whether it's visualizing the base station itself, the home environment, and so forth. CDN, this is another use case which is also very important to us as Orange. So you can see that we cover, you know, a wide range of use cases, anything that essentially you can think of today. And if you have more ideas, feel free to let me know. So as I said, I'll come back. I'm coming back to the network functions forwarding graph. This is the official term that we use for something that's known as service chaining. It's a term that I don't personally like, service chaining. I prefer the term service composition and insertion. But if you've heard that term before, that's what we mean by the network functions forwarding graph. It's all about how you can actually stitch together those different VNFs. Again, we going from a static environment where everything is connected in a very static way, right? You have wires running between the different devices, going to a very dynamic environment where you have all these different functions running on VMs that can be located anywhere in your data center or even across other data centers. So how you actually stitch those things together, you know, how you link them, that's what service chaining is all about. And the interesting thing about service chaining is that since this is a very dynamic environment, what I show here is essentially I show a number of network functions here on top. You have your virtual suites and you have your physical suites. So once you start chaining these things, what the interesting thing is that you can chain things differently depending on the user or the application. So if you're George and you're running a particular service, maybe you don't want the firewall, which I doubt, of course, but maybe you don't want to have the firewall function as part of your service. So you can actually, you know, bypass that. So that leads essentially to building customized chains, depending again on the user, depending. Let me go back. Depending on the application, depending on the profile of the user, any criteria that you set up. And in fact, you can make these programmable. So I can say, you know, for that particular user, you know, use this chain, and you know, for that user, use that chain. And if something changes, you know, perhaps also you can change the chain itself. So I think that's what, again, it's all about software and the power of the software that gives you. Right? I think software is king, and obviously it will eat everything, as Anderson has said. So that's all about the service chaining. Again, you can build those customized service chains across your network. I think this is a really, really powerful statement as far as Nfv is concerned. I did mention that we have launched that POC program. So in case you're not aware, ARM is involved into a couple of proof of concepts. The first one is proof of concept number 19. It's about service acceleration on network functions for carrier networks. Again, it's trying to showcase how the orchestrator is able to set up the multiple functions to be offloaded from the actual physical equipment onto VMs. And you participate in that POC with Vago Technologies, Ericsson, Tieto Procera, which is a deep packet inspection company, and AT&T. This service has been underway already. And I think they're going to showcase some of the results from that POC in the upcoming Nfv zone in Düsseldorf next month. And the second POC, which has been just submitted, it's about the VPC, the kind of things I talked about before. The VPC is a very, very important, again, use case for everyone involved in Nfv. For all the operators, we understand the importance of being able to visualize the entire architecture. So let me dive a little bit into the POC that you are working on. So again, this is the classical model of the carrier today, where you have the network elements and you have the different appliances, firewalls, the backend inspection, load balancers, and so forth. And these again are connected in a very static way. As you can see, it shows the control path and the data path. And in the proposed POC, you see that these functions are now being visualized. They're running on commoditized servers. There is something called the Nfv Orchestrator. The job of the orchestrator essentially is to maintain those virtual machines, right? It's all about the management, lifecycle management of the virtual machines that are running on a server. And so you see this picture is obviously different than the one before. It also recognizes the importance of acceleration, because one of the things that really comes up when you start visualizing things is performance, right? And performance here means things like delay and quality of service and things like that, right? Because you're going to an environment which is uncharted, essentially. You don't know what's happening. You have no control of how traffic flows between the different VMs and so forth. So performance could be an issue. And we do know that for certain applications, you may have to accelerate handling these virtual network functions. So this POC is, of course, related to that. This is the reference, the software architecture that they included in the POC. I'm not going to go through the details. So there's like a number of goals that have been set out with respect to the POC. Verify the acceleration of the visualized network functions. Demonstrate this VNF disaggregation. Again, it's how you can move out from the hardware, from the device, all these network functions, and move them into commoditized servers. And the other thing that I want to point out, because again, this misconception is that people think that this is only related to x86 architecture. This is completely wrong. If you look at the white paper that we did a couple of years ago, we don't really mention anything about x86 or even that has to be visualized. All we're saying is that you can move those VNFs into commoditized servers. That's the base premise of Nfv, right? It's not about x86 or about virtualization. Of course, if you're going to be using VMs, that will make things much, much easier. All right. So one of the things that we're very careful in sort of including in the white paper, again, a couple of years ago, is to essentially craft a story behind the other ongoing efforts. And so we have this now famous Venn diagram that talks about open innovation, so open source and other relevant efforts, like the OCP project with Facebook, can go under there. We're also very much aligned with SDN. We think that SDN, of course, can be a great tool for us. In fact, one of the things I say is that perhaps Nfv can become a killer app for SDN. And also you have the network function visualization. As you see, they're all kind of like, they overlap at certain points. They don't overlap 100%, but there are a lot of synergies, especially between SDN and Nfv. So we also claimed early on that Nfv and SDN are highly complementary. They're mutually beneficial. They don't rely on each other, so you can have SDN without Nfv and vice versa. But if you combine the two, you get the greatest value of both. When you look at things like SDN and Nfv, software is again the common denominator, and that's what we think is very, very, very important. The other critical thing that we have launched as an effort this year was around open networking and Nfv. So things like what should be open come to mind. Okay, we're talking about the software, you're talking about the design, whether it's like hardware, open standards, open interfaces, open SDKs, and so forth. So this is like a simplified model of what I consider an open network system. You have the applications running on top. Applications again are very, very important. You have a network operating system, and then you have the hardware and software on the bottom. Hopefully this is quite aligned with your ODP architecture as well. An open community, of course, you do need an open community. We want to make sure that this is a multi-vendor effort. It's not controlled by a single vendor. So things like Linaro, of course, are very relevant to that. Let me move on here. It's all about decoupling software from the hardware. Benefits, I think this is sort of like easy for everybody to comprehend. Once you start modularizing things, right, when you go into this disaggregation model, you can choose the best of breeds for each component. So you can choose the best software vendor, the ISP for a particular application, and so forth. So I think that's what's really benefit of when you go to an open platform. Customization, reduce cost, this is things easy to understand. There are some issues, of course, when you're dealing with different components from different vendors, how you can actually integrate these and make sure that you end up with a consistent system. That's obviously might be a challenge. For us as operators, you have to make sure that any open networking solutions are carrier grade, because we need the SLAs that we have to adhere to. When it comes also to high availability and 5 nines and things like that, all the nice things that you guys know about when it comes to carrier grade SaaS solutions. And of course, security is always of paramount importance here. Ideally, we'd like to have a sandbox of open source tools that we can go and choose depending on the scenario and the application that we want to run. I think that the virtual suites component, the virtual suites can play a very, very significant role when it comes to open source. In the picture I showed before when I was talking about service chaining, as you see, all of these different chains go through that virtual suites. And I think that can play a very key role. I think I have a slide on that later on. Actually, I do mention that here, that it's very, to us, is very critical. To me personally, I think that can be the key building block in the service chain. Okay, so Nfv and SDN, again, we think, again, it's very, very important. SDN can play a key role in the orchestration of the infrastructure, whether it's visual or physical, because what SDN does is it does give you sort of like a logical map of the network. And so when it comes to provisioning VNFs, or how you can, if you have to move VMs around, SDN can be an important tool there. How you can apply security and policy to the different VNFs also is very relevant when it comes to Nfv and SDN. I did talk about the service composition, the service sending thing, how you can direct traffic flows. I think, again, SDN can be instrumental there due to its programmability aspect. You can program things nicely in SDN, so you can actually do some traffic steering along the way. So again, I want to re-emphasize that Nfv creates a very dynamic environment. And again, with SDN, you get that logical network map view and also the programmability tool. And the other thing that is also becoming relevant is how, if you have all these VNFs running in your data center, right? At the same time, you have perhaps tenants that these VNFs belong to. So you need to set up those virtual networks, the virtual tenant networks, and these networks have to be isolated and secure. So that's going to be another challenge for when you go to an Nfv-based environment, and we think, again, SDN can play a key role there as well. I'll probably skip the challenges in dovetailing SDN and Nfv. Again, these things are easy to understand. When you're trying to introduce new technology, you have to deal with legacy equipment. With also things like organizational issues might also come up. How do you educate your staff to adapt to this new environment and this new paradigm of Nfv and SDN? And but again, we think that SDN and Nfv together can create really great value. Mapping to open source communities. This is again the same reference model that I presented before. You can see how the different open source communities map into this architecture, and you can see ODP right there. We hope this is correct. So obviously there's a lot of opportunity for you guys to be involved in that at some point, and we would like to see that. We are launching something called Open Platform for Nfv. It's semi-official at this point. I think there's going to be an official announcement later this month. This is going to be under the Linux Foundation. Again, the goal here is to create an open platform for integration testing and validation of these all these different NFV concepts. Now, with respect to NFV and ODP, as I said, it's quite relevant to the work we do. This is the reference. This is the architecture on ODP, and again, ODP provides sort of like a cross-platform multi-vendor support for APIs to the network data plane. So the keyword here is APIs, and I'll come back to the APIs issue later on. It does support the SOC abstraction. Again, allows for APIs to access the SOC's resources directly, and also execution in Linux user space. So going back and plugging in the POCs that you guys are working on, as you can see, this is the first POC. And by the way, this is slides that I got from you guys. It's not my slide. So I did not make it up, but I'll be happy to share that with you. So you can see the acceleration, the service acceleration as VNF1, and the VPC is another VNF itself, and it's running on the ODP APIs, and you can see the rest of the architecture there as well. And again, the important thing again is to keep in mind this management orchestration aspect of NFV. If you look at the overall picture of how virtualized network software platforms are evolving over the years, this is like the full picture. Again, having an ecosystem that's very inclusive is very, very important. You can see the different VNFs running on top. And again, this is a picture I borrowed from ODP. All right. And I believe that these slides are going to be made available somehow, right? So I don't need to spend more time on that. So going back to the role of APIs, again, APIs are very, very important because at the end of the day, we'd like to offer more services and new services to our customers. We'd like to see new applications being developed and integrated into the NFV environment. This is very important if you're dealing with open platforms. Companies like Google and Facebook and Amazon and Microsoft have been doing that already. So we just, as telcos, we're trying to catch up with them if that's possible at all. The significance here is that once you start integrating those APIs in your network, as far as service providers are concerned, you're moving from a function service-based model into an application-based model, right? So what you're like to offering to your customers is more like application than services. So I think this is what's really interesting to us as network operators. And the other thing that is kind of interesting is that how you integrate this intelligence in the network, how you can allow your customers essentially to also bring and write their own VNFs, right? So that's another aspect of API. So again, API is very, very important. You see a lot of efforts around APIs from other operators as well. We are also very keen on that. And again, it's all about empowering the developer and the user when it comes to things like NFV. So I have some concluding thoughts here. So if you look at the infrastructure, typical infrastructure today, for instance, if it's like a network operator, so you see all these different isolated networks that are really scattered around. And you have one network, and they have another network, you have a third network, and these networks, sometimes they do talk to each other, or sometimes they don't talk to each other at all. But what you see here is they have a number of perhaps sometimes heterogeneous networks, and there's also lots of duplication. So for each network, I need a firewall, I need a deep packet inspection, I need some other type of equipment like load balancer and so forth. So obviously, this is not cost effective, and it's not efficient either. So in this new world of NFV, what's happening is that you move all these different functions into VMs, and these again functions running on VMs. So these VMs can be scattered around; they don't have to be collocated on the same server. Ideally, they will be located on the same server, because of performance issues, but you don't have to. And this is like some forward-looking picture. Even if they're not located on the same server, all you need to do is provide very high connectivity among these VMs in order to deal with all these delay issues. So, so this is like sort of like food for thought, how we can do that one day perhaps. And everything is going to be on the cloud, because everybody today is talking about the cloud. And again, these VMs can run anywhere. If you ask my personal vision, maybe one day, one VM can be running on your mobile device or your smartphone or your smart tablet, for instance. And as long as you're connected with another VM, maybe you can run, VNFs on those VMs, right? So that's why I'm saying it's a little bit more like forward-looking. So hopefully, this happens one day. Again, Nfv removes all these physical boundaries, essentially, and constraints from your infrastructure, and it breaks down these barriers and opens up to unlimited opportunities. Let me say a few things about what we do here as Orange. I'm not going to go over that slide. Orange is essentially France Telecom Group. We're building a testbed in our office I'm out of the office here in San Francisco, and we're building a testbed that actually integrates Nfv and SDN. In fact, we call this the Net Squared Studio for Nfv times SDN, essentially. And we started actually our involvement in Nfv with building the virtualized EPC, the Vault Packet Core. We think that this is, this is very, very exciting for us. And the reason we are working on that is because once you start deploying things in environments that are not really that friendly, perhaps or you don't own the infrastructure, as we expand in Africa, for instance, maybe we don't have access to infrastructure there. Maybe there's no infrastructure at all. And so you have to be kind of, have to innovate. So we think that once you start visualizing these things, maybe it makes it a little bit easier to deploy things. But personally, I call this VPC in a suitcase. In fact, you can get the VPC software even on a thumb drive, so it's not even a suitcase. So, so when it comes to VPC, it's not just about virtualizing a single function. It's, again, virtualizing the entire architecture. And what we've seen in terms of approaches is that one approach is what I call the verticalized visualization of the EPC, where, in fact, you can take the different boxes that exist today in the mobile packet core, the MME, the SSS, the PCRF, and so forth, and map these into VMs. That's one approach, right? There are other approaches as well, which actually call for the disaggregation of these boxes. So essentially, instead of mapping a box to a VM, you just break down that box into a number of functions, and you map those functions into VMs, right? And that gives a little bit more flexibility because, let's say there's a spike in my network, and if I need more, if there are like more subscribers coming in, maybe I just need to increase the capacity for the MME. Maybe I don't need to increase the capacity for the PCRF, right? So in the old example, you have to duplicate everything, essentially. But in this new example, you just need to scale up and out only those functions that you need. So we think that this model is kind of more interesting. It's a little bit more challenging. We've been working with startups on that. It's not really straightforward, as one may think, but I think this is exciting. And if you look at that, it sort of like breaks down, in a way, the standard architecture for the EPC. In a sense that, again, it calls for the disaggregation of the node. It doesn't really break down the standard itself, but how this, so that it maintains the same interfaces, but with respect to the actual architecture per box, it's sort of like, makes it a little bit different. So I think this is very, very exciting, and essentially that leads to the cloud EPC, where you can actually, once you virtualize the EPC, you can have a number of mobile operators, network operators, essentially getting a slice of that EPC, right? So, so as Orange, perhaps, we can say, okay, if there's like a third party that wants to use the services, we can open it up and say, here's a slice of that EPC. So, it can lead to more revenue, essentially. And again, the management orchestration is always going to be there. So this is the smart EPC testbed that we're building in our office, in our lab in San Francisco. I'm not going to go through more details of that. Again, it's about integrating SDN and Nfv So the one point I would like to make here is that we've been working on an application called traffic offloading, how you can offload traffic, and this may be quite relevant to you guys. One of the pain points for us as mobile operators is traffic offloading, right? How can offload mobile traffic from a 4G network to a Wi-Fi? And today it's been done in sort of like a crude way. Okay, if I see, once you have access to Wi-Fi, you immediately offload it to that Wi-Fi. But there should be smarter ways to do that. Perhaps if I'm a premium customer, I should not offload my traffic to Wi-Fi because maybe there might be some performance degradation there. So the inherent value of things like SDN and Nfv is that since things are like in software, I can inject a software solution into that into that product, into that architecture, and say, okay, I want to offload traffic in that particular way. I think that's one of the inherent also values of SDN and Nfv, because I think in the past I had to go to Ericsson or I had to go to Nokia Siemens and say, I have this great idea about how to do traffic offloading in my network. Can you please add that to your equipment? And because I'm a big customer, of course, Ericsson will do that, but it may take 2 to 3 years for them to implement it, right? But now I don't have to wait. I just need to go to an independent vendor, to an ISV, and say, can you please develop that solution for me? And this is my environment. This is what's been running today, and they can come in and implement that. I think that's really, again, great value for us when you go to Nfv and SDN. That's all I have. This is something which is we launched like last year. We have an accelerator program, again, out of our office here in San Francisco. We invite startups to come and work on exciting things, like very small startups, not more than 5 people. So if you guys are interested, feel free to contact me. Again, we have great facilities down in San Francisco. We're going to open up the Orange Fab thing at the end of September again. And also the other thing that we launched recently is called the Giga Studio, where we provide gigabit connectivity, again, to startups that they want to come and test their solutions with us. Okay, so with that, again, this is my last thing. It's like Nfv, we think, will profoundly transform the network as we know it today. And with that, are there any questions? Anything that was not clear, or anything that you think it's a burning? We have time for 1 question or 2 questions, maybe? 2 questions? Nothing? Okay, I'll be around in case you want to talk to me. Okay, thank you, guys.
Thanks, Christoph. So it was pretty good. So I would like to invite all of you for our demos today afternoon. So the theme is free up the data plane. So thanks for your session. So you're not only freeing up a data plane here, so I know that it is going to free up the whole infrastructure as well as the service providers from the hackles of dedicated hardware. So I think this is going to be challenging and very interesting time for networking. Thanks a lot.